welcome. Welcome. Spread it out. All right.
The planet is burning, and we've run out of time to do something about it. 8% of all greenhouse gas emissions come from waste food. We use 25% of our power into food. The tragedy here is that almost a third of our food is lost in the cold chain. We spend $6 billion a year just on fuel for refrigeration and transit, and this means 29 million metric tons of CO2 equivalent emissions every year in the US alone. And that's why our beachhead market is in refrigerated trucking. These customers are always looking for ways to cut fuel costs because they have razor-thin margins that they're trying to expand. But distribution is really just the tip of the iceberg as far as the impact that we can have in New York State and in the Grow New York region. Some of these areas are with milk production, power generation and storage, and actually out in the field as well. My name is Romy Fain. I'm the CEO of Heat Inverse. This is John Bailey, our CFO. And along with the MBAs and PhDs from Cornell on our core team, our mission is to revolutionize cooling technologies and profitably reduce greenhouse gas emissions. We make thin films that get cold without any additional energy input. And they look like this. We have two versions. One that's gorgeous, very highly reflective, and one that's transparent to visible light. And these films, we can basically increase the efficiency for food production and food distribution, but as it relates to refrigerated trucking, we can, oh, sorry, my slides are forwarding before, there it goes again. So we reduce fuel costs, food waste, greenhouse gas emissions, and I don't know why it wants to go forward on this slide. It didn't do this in the practice. And also extend asset lifetime. And we do this with zero moving parts, zero power consumed, and none of the waste heat that's generated from conventional cooling systems. Now, do the slide now. I just want to tell you a little bit about the physics going on here and how it works in a nutshell. So the atmosphere of the planet is transparent at some wavelengths and not at others. And that's where we see sunlight from the surface of the planet. But what we're doing is we're focusing on these longer wavelengths, these windows in the atmosphere at longer wavelengths, and we're creating these hyper emitters that emit really heavily where the atmosphere is transparent. And when you do that, you can access the cold sink of space from the surface of the planet. And that's like the biggest cold sink you could ever find at almost 0 K. And what we get, just due to second law of thermodynamics, or heat always wants to go from hot to a cold surface, we get about 100 watts per square meter of cooling, or roughly 10 degrees C at room temperature, and higher capacity cooling at higher temperatures. With a simple application of these thin films just to the tops of refrigerated trailers, we can provide 5 kilowatts of passive cooling. Oh, it's forwarding again. and that just happens to be about 25 to 80% of the fuel, or the cooling capacity that's needed for cooling these trailers on average. And we're pricing our films based on a 1-year return on investment for these customers at $2,600 per trailer. Now this is my favorite slide, hopefully it stays put. We have great unit economics. Basically it boils down to the cost to manufacture these films is really low, and the value simultaneously that we can provide for customers is really high. So we're looking at really high gross margins almost out of the gate. And after more than 300 interviews and customer interviews in this industry, we have found that we can more than meet expectations of the customer, both on increase in efficiency, but also that return on investment. So we can provide the customers a 1-year return on investment, but still be making this 80% gross margin. And this is, if you obviously you know this is unheard of for a hardware startup, a clean tech startup. 80% gross margins is sort of more like a software. And so all of this results in a huge market with a huge impact, and based on the number of trailers that are existing, annualized, so 1/5 of the existing number of trailers, the opportunity globally is $1 billion and 260 million in the US. But we're really hyper-focused on this 121 million opportunity with companies that own large refrigerated trucking fleets. And we will really dominate this part of the target market because we can excel in areas that are important to the customer where some of our competitors are lacking. So we know there's no other company out there that can provide 25% high cooling savings, fuel efficiency savings, at low cost, high durability, and easy application. And we're in the middle right now of scheduling pilots, organizing pilots with a lot of different companies, both in our target market and beachhead market, and also in our follow-on markets. And we're doing that in the Grow New York region, and New York State, nationally, and internationally. With companies like Wegmans, GNC Foods, Cornell Dairy, Andrew & Sons. This is what our, and I also want to point out actually, we're implementing these pilots this year, beginning this year. And some of these pilots are paid pilots, but we also have agreements to purchase from some of these customers based on completion of a successful pilot. So this is what our timeline looks like right now. We have just completed, as a result of our successful SBIR phase 1 with NSF, these pilot scale films. So that's like 10,000 square feet of 1 foot wide films. Finally, we have something to pilot with. So that's what we're going to be doing. We're going to be implementing those pilots through the end of the year, and we've already started production on our 90,000 square foot production line, which is 1 meter wide. And those will support our commercial launch in the first quarter of next year.
So our financials are pretty typical for a startup. Year 1 is commercialization and some early traction. Year 2 is growth. Year 3, break even. Looking at our revenue growth, we think is fairly conservative given we have multiple segments. Competitor in the space has annual revenues of $28 million, so we think we'll be able to get to that point pretty soon. Our gross profit margin is 60% in trucking, which is pretty substantial. We have other segments that have smaller margins, as you'll see next. These are our 2 largest segments. Our refrigerated trucking is our first, but companies like Con Ed and Power Storage, looking maybe for tens of thousands or hundreds of thousands of square feet of film, have much smaller margins. So we're going to be aggressive in pursuing agriculture with the better margins. So we have a lot of different applications, from reducing heat stress for cows, reduction in cost for milk cooling, picking tents to increase shelf life, ground cover for root protection, and overall energy savings for food storage and cold chain. And we're going to rely heavily on our New York region partners for these connections, opening doors, making sure that the folks we're reaching out to know that we're legitimate and our technology works. We think there's going to be significant growth in manufacturing in the region as well. And obviously, so we have some key advisors filling in some where there are team gaps in agriculture, economic development, product management. We're working with 20-plus professionals that are looking to join the team, part-time and eventually full-time. And already our sales team has been giving dividends in logistics, energy, and technology. Team capabilities are very strong in startups and engineering. For regional job creation, we're looking at senior leadership all the way through administrative roles with an average annual salary of $75,000. So awards from Grow New York are going to accelerate jobs. They're going to accelerate revenue in the region. The larger the award, the larger the acceleration. In global reach, we're accelerating. We have pilots scheduled in Mexico and Colombia, among other countries, and we're talking with Nigeria and India, where there's a lack of food security.
If you know our company already, you've seen our this kind of cooling capacity that we're talking about today and many testing setups that we've shown so far. But if you're interested in seeing more details on that data, come and see us at the kiosk or talk to us afterwards. But we also have our brand new ice melting demo, which I'm excited about because it's very compelling. It's where it shows that the ice melts so much faster without the cooling film than with. But why we win? We've shown.
Hey, Romy, this is a good slide just to have up because we're a little over time.
Okay,
You
great.
just have this up and you can speak to it when the judges get their questions to you, if you don't mind. John C., why don't you jump in with your first question?
Yeah, first of all, great presentation, and really like the technology you're talking about here. I guess my question is, you talked about trailers as a beachhead, but my mind and just thinking about other applications, seems like there's broader, bigger applications that might be easier to jump into. I'm curious why specifically trailers.
Yeah. Thank you for that question. You're not the first person to question that. So multiple reasons. So our mission is to reduce greenhouse gas emissions as well. So we're sort of a triple bottom line kind of company. So there's a lot of emissions that come from that. But we've also just found in a technology like ours, where there's so many applications, you can really be in trouble with maybe trying to boil the ocean. And that has been one of our big problems early on, is like trying to figure out where is the best place. It's definitely one of the best places because the need is so great and the value that we think we can generate for those customers is so much more than what they would expect. So it's sort of a home run on lots of levels. It's reducing those emissions, really great margins, and compared to something like a Con Ed or for the power industry, which we expect to move into later with larger volume sales, the per square foot value is lower, but it makes up for it with the volume.
And we've done a lot of customer discovery in the field as well, more than 300 conversations.
Yeah. So
we know the market.
Yeah, so sorry. 2 NSFI cores, boot camp for the SBIR Phase 1, Clean Tech Open, many programs that we've been a part of. And so we struggled a little bit early on with getting the materials to this stage because we had suppliers that fell through multiple times. And so during that time, what we did was we did a lot of customer discovery, and so that spring has really been compressed. We know who we need to talk to now. It's just now we have the film. We can go and do that testing.
Let's go to Mary for another question.
Yeah, thanks. Kind of building on that question about, why trucks. I'm just curious from a technical standpoint. I understand the need is really there, and I completely agree with that. But it still seems early. Do you have any data yet on trucks? I know you're talking about you're going to do trucks, but any data yet on trucks for these trials that are in process? How are they designed? What are you comparing them to? And also kind of a third part of that long question. Any concerns about getting a performance difference on a moving object rather than something that's just fixed all the time?
Yeah, okay, so for the first part, no, we do not have data on trucks yet. The closest thing we have is on portable refrigeration units. So it's, it's using electrical power. So here on the right, you can see our fridge demo results. You can see it uses a lot more electricity without the film than with. So it's sort of the closest demo that we have. We have done a lot of testing, though. Otherwise, we know it cools. We know how much it cools. You're right. I mean, the proof is in the pudding with the pilots. But what's in support of that is the trailers are not meant to take something hot and cool it down. It's meant to maintain a set temperature, and because of that, most of the cooling that's needed is because of heat seeping in from the outside. So it's pretty good. I mean, we can't say for sure until you do it, in person. But I think it's pretty compelling, and also simulations and things like that.
So you're not concerned at all about any difference in how this is going to perform from a physical standpoint in terms of something that's just sitting there versus something that's in motion?
Yeah, no, I think, so first of all, sorry, I missed that second part. So the convective losses happen in parallel with the emissive losses. So those two cooling functions or the methods of heat transfer are still going to be happening, but the convective losses may overpower some of the emissive cooling at times. But what you'll see is that a lot of times, a lot of the power that's going, and fuel usage that's going into these is when it's stationary. They'll be running it overnight, or they'll have a bunch of trailers in the yard and just burning diesel.
Great. So John Eng, do you have a question?
Hi.
Hi.
Very interesting technology. Are you, or where is it being manufactured now, and are you talking about bringing manufacturing here to New York?
Yes. So the 5-year plan is to have our manufacturing facilities here at home in New York. So we're based in Ithaca, New York. Everything is going to be here. But right now, just due to necessity, we've had to do some of the parts of our chain outside of New York State and outside of the Grow New York region. But we are working with CAM in Binghamton, obviously CCMR, Cornell Center for Material Science. We do a lot of our measurements there, and Eastman Kodak. And so, we're doing as much as we can locally, and we really want to continue to expand that. But for now, we can exceed our 5-year projections for the amount of films that we need in this supply chain that we've already sourced and are making more robust by repetitive leases at this point. But like I said, the goal is in 5 years to build our own facilities and have our own line. And so people like companies like Davis Standard, we've been talking to them about how much that line will cost.
Yeah, and also given what we're seeing around the world for supply chain, we want to control it, right? So that's obviously a priority as well.
Laura Peterson, you ready to jump in with a question?
Yeah, I'm not sure if you could answer this actually. If you haven't actually tried it on trucks, I wonder how long you think it would last once it was on the truck.
Yeah, so we actually have some funding to do. We haven't done that longevity testing yet, but we have some funding to do that accelerated aging testing at Intertech. But based on the base polymers longevity outdoors, that we picked it for long durability outdoors. So although we don't have the numbers for the aggregate film per se, we do have it for a dominant portion of it that we think it's going to be fairly close. And when you look at the graph for that, it's just flat past 10 years. So we're estimating 5 years as far as our projections go. I mean, maybe there would be some other weaknesses in that durability that would be introduced, but so we're estimating at this point, but it's on our radar to get that data.
Mary, why don't you hit us with one more question? We'll squeeze it in here.
Sure. Let's just thinking about this, important from a standpoint of patent protection. I know you filed for your patent. Kind of what's the status on that? And maybe a backup question too. And I know the field of metamaterials is extremely hot right now, and there's a lot of patent work. Is there anything that would actually block you from what your application is by the more fundamental patents?
Yeah, so first of all, we have filed, as you know, we've filed both in the United States and 11 countries otherwise. Where we are right now is we're following through with all of those, obviously, but the most recent action on that is that the USPTO, they wanted to split it into 4 different patents, because we just put the kitchen sink in. So we're doing that stepwise. And then as far as concerns about, there's always concerns about, hopefully somebody else doesn't do this. So there's sort of the normal concerns. But I would say when I started this, I was very concerned. Like I really didn't want to talk to anybody about it. But since then, I've learned that I have a sort of special skill set. Thermodynamics meets photonics, and there's not a lot of that. So usually when I talk to people about it, it takes people, even people like myself, it takes people a while to really fully understand it. And that's a pretty big barrier.
Great. Let's give Inverse a hand. Thank you very much.